In this video, we're going to try to understand some basics of understanding chemical reactions. We really want to try to learn what important information we can get from chemical reactions, what a chemical reaction really means, and then what's happening during a chemical reaction. So let's start with that first question. What does a chemical reaction mean? And for this, let's take the reaction where we have methane here, reacting with oxygen to form carbon dioxide and water. You're probably familiar with this, but the compounds that are over on the left side are our reactants, and the ones that are on the right side of that arrow represent our products. And when we see a reaction like this, there's actually a number of different things that we can get out of it. First, we can consider this as part of a triangle of information. We have sort of the symbolic representation, right? So here we've represented in letters and numbers what it is that's going on, and that actually has a lot of meaning to a chemist. Because a chemist can look at that and start to then consider, well, what do these actual molecules look like? And how are those different atoms rearranging as this particular reaction occurs? When we look at something like this, we're actually considering what's happening at that particulate level. So what are the individual molecules? What are the individual atoms do? What kind of rearrangements are happening there? From that original equation, we could also be thinking about, well, what happens when we have methane burn? And so you're probably familiar with methane burning. Often in Michigan it's used to heat our homes, or if you have a gas stove, those typically run on methane. So we could be thinking really about what's going on at that macroscopic level, that what we can see. Because when we talk about the particulate level, no matter how much we try to zoom in on those, if we're using a microscope or whatever, those are always things that are too small for us to see. And so when we're talking about the particulate level, those are submicroscopic, so things we can't see, but we can also think about reactions at that macroscopic level. Now, this is actually an important reaction for some other reasons too. So you might be familiar with methane. It's one of the fossil fuels that we use. And if we look at sort of a history of the amount of carbon dioxide or methane that were in the atmosphere, what we see is that it was actually pretty steady for a while here. We can see the carbon dioxide in red. And somewhere around 1850, all of a sudden this took off and shot up. And you probably have a pretty good sense of why, right? That was when the Industrial Revolution happened. All of a sudden, fossil fuels were sort of discovered, and we realized the value that they could provide in providing energy and improving life for people. But what we also see is sort of the downside. Right? Here we have this reaction where we take methane and we convert it to carbon dioxide, and what we see is once that started happening, we started burning all that methane and other fossil fuels, we started to get a lot of carbon dioxide in the atmosphere. What you'll see is the blue's also gone up, so now that we're mining more methane, we actually get a lot more that's released into the atmosphere as well. So both of those have some concerns that certainly are coming across, and you probably know those concerns a little bit, because both methane and carbon dioxide are known as greenhouse gases, and they're leading to the heating of the planet. But when we're thinking about this, we might also be thinking a little bit about the cycle of carbon dioxide, right? So here we know there's a lot of carbon dioxide, but we know that there are different processes that are going on there. So if we're really trying to think about greenhouse gases, we would want to consider, oh yeah, a whole bunch of, these are, I believe, billion tons. So this is how much CO2 is actually going into the ground and into the earth through photosynthesis. So we see that, a lot's being taken in there. But if we start to look at all the different possibilities, we say, well, right now there is this net increase in the amount of CO2 that's going into the atmosphere. And again, that's what's leading to global warming. So we can also really step in and look a little bit more closely at what's happening during a chemical reaction. When we have a chemical reaction, as you can see down here, we start with methane. Remember when we have the letters here, that's indicating the phase. So here we have methane as a gas reacting with oxygen as a gas. What that reaction means is that those molecules are going to rearrange. And so in this case, what we see is the methane is going to be broken down, the carbon is going to reconnect with new oxygens, the oxygens are going to connect with the hydrogens. And so what needs to happen in order for this to occur is that we actually need to break some of the bonds. So we need to break some of those bonds that were originally in the reactants, and then we're going to form new bonds in the products. And I'll point out, in this case, all the different bonds are broken, but there's a lot of chemical reactions that happen where not all the bonds are broken, and we don't necessarily take everything back down to the atoms. And I'll also say it doesn't necessarily quite happen in the way that it was depicted here, but it really is helpful. And we know that when this happens, though, we actually will get energy that's released, right? You know that the combustion of methane gives off energy, and that's related to those bonds and the breaking and forming of new bonds. And so if we consider this, there's a couple things that we really can pull out. So again, when we see a chemical reaction, we know that atoms are going to rearrange to make new molecules, that the bonds are going to break and reform to allow that to happen. We'll also see that the total number of atoms actually remains constant. What we notice is we could translate each of those atoms one to the other from the reactant side to the product side. We didn't have any new atoms that were created, we didn't have any that were left over. When we have a chemical reaction, again, all of those are accounted for. And that's what leads to that idea of conservation of mass. The other thing that's important is that when we have these new molecules, we actually get new properties. So for example, you probably know that if you have O2, you can actually burn something. But if you have water vapor or if you have carbon dioxide, those two don't allow us to actually burn something. So again, we've rearranged these things to make new molecules which are going to have new properties.